Hi, we are going to continue our discussion on sets and Venn diagrams. So let's start with this simple example. We have this situation. We want to shade the region or the part that corresponds to A complement union B. So let's see, we're trying to do union of two sets, correct? So the complement of A will be everything that lies outside of A. So that would be everything inside these boxes except what's inside of A. Correct? So if you shade it lightly with a pencil, the complement of A is going to be this. I will go over that with a darker color to finalize my answer once I'm done. So that would be the complement. All this is the complement of A. And we do trying to do a union of that with B. So B is everything inside this circle. So that would be going this way if I go in the different direction. So all that combined will give you, since we're doing the union, all that combined will give you the union. So a resulting thing is going to be this whole entire thing, except that little crust-shaped base region, right? So the next thing, B, we're trying to do the complement of the intersection of A and B. So where is the intersection of A and B? Hopefully from the previous lessons you know that the intersection of A and B is going to be right there, that overlapping part of the two circles. So what is the complement of it? The complement is going to be everything that lies outside of it. That means our answer for the for the complement is going to be all this, right? And let me clear the part that we actually don't need to have shaded, just to avoid any confusion. So there's nothing shaded in that middle overlapping part. Okay, moving on. So now we have to figure out the regions that correspond. So if we're looking at this diagram, all these regions are numbered. So 1 is everything that's outside of A and B. 3 is the part that overlaps. 2 is this crest-shaped part of A, and 4 is this part. So the question is, what corresponds to A? Well, what corresponds to A is everything that's contained in A. That would be regions 2 and 3, right? It doesn't matter if this part overlaps with B or not, it's still part of A. So for A, that would be 2 and 3. What corresponds to the complement of the union of A and B? Well, let's see. The union of A and B is going to be all that part, right? Everything that's is contained inside of A or B. So all this here. So the complement of that will be everything on the outside. That will be region 1 only. Okay, this is where it gets trickier, because now you have to figure out what set is given to you, and you have to describe that using set notation. There may be more than one way to do that, so I'm not going to delve into this, but we are going to talk about the possible way to describe this. So how can we imagine this? What do we have here? We have A, that's here. What else do we have here? We have everything that's outside of B, which would be B complement. So right here, everything that's outside of B, just ignore this shaded part. This part here, everything outside of that is the complement of B. This here is A. So if I do A union the complement of B, this will give me my desired set. Okay. There's another way to write that. I'm just going to throw it out there so you can see it. You can actually write that as the intersection of the complement of A and B, the complement of that. That's another possible way of writing that, but that's a little bit more advanced maybe at this point. What about B? Well, B should be easy because B is actually everything that's outside of A, which by definition will be the complement of A. So this is the complement of A. Okay? Let me put or here so you can remember that it could be one or the other. Alright, next one. Now we get into three sets and it gets really interesting. So here I would recommend that when you have problems like this, you actually go slowly and shade what needs to be shaded. So first of all, we have a union of A and B. The union of A and B will fall right here. That would be the part where A and B are simply joined together, right? And then we're trying to do the intersection with what's not in C. Well, this gets really intricate now because what's not in C is everything that's going to lie outside of circle C. Right? And what we need here, because we're trying to do the intersection, is we need to find the part that overlaps. So what's going to overlap here is, I hope you can see this, is this part along with this part, kind of like Mickey Mouse ears, I guess. I don't know if it's a good comparison or not, but this part here where we have two shaded directions, one going this way and the other one going that way. We want to see where they overlap. So for that, the answer here is going to be, let me go in a different direction. Okay, so everything that is shaded in the marker is what we need. Everything that is shaded in pencil is not part of that, so we can clear that. Okay, I'm going to clear that so that we don't get confused. Alright, so that would be the part, the region that corresponds to that. Alright, so now we're going to do a similar thing, but we need to figure out the regions that correspond to this. Well, let's take a look. So we have a union, right? So if we're doing the union of A with something else, we know anything in A will be part of that, since we're going to do A plus add something else to that. So what's in A? In A you're going to have 2, 3, 4 and 5, right? These four regions here, 2, 3, 4 and 5, make up A. So we need to add something to it. So we're looking for the intersection of B, which is this circle, with not C. So not C is what lies outside of C, right? So let's take a look. So B, this is probably the easiest way to do that. B is made up of 5, 6, 7 and 8, right? 5, 6, 7 and 8. Now remember, these are not elements, these are just symbols we use to represent. It's just easier to use Roman numerals to avoid any confusion. What makes up C? C is made up of 3, I apologize, this was not 4, this was, okay, let me make this correction here. This is 6, and this is 6 as well. Let me actually write it here. Okay, so this is 6. So 2, 3, 5, 6, 2, 3, 6 and 5 make up region A. 5, 6, 7 and 8, 5, 6, 7 and 8 make up region B. Region C is made up of 3, 4, 6 and 7. 3, 4, 6 and 7. So let's start by figuring out, so the intersection of, and what is not C? So not C, since this is what we're looking for, is everything that's outside of C. This would be region 1 and 2, right? Everything outside of C is what we're looking for. 1, 2, 5. They don't have to go in order. 1, 2, 5 and 8. Because these are the regions, the parts that are not inside of C. Because what we have inside of C is 3, 4, 6, and 7. Right? So we do 1, 2, 5, and 8. So what is the intersection of B and the complement of C? Those would be the regions that they share in common, right? So they don't share 1, they don't share 2, they share 5 and 8. So it would be 5 and 8. And now we're trying to do A union with that. So what's going to make it up? What we have in A plus this. We already have 5 in common. So that would be 2, 3, 5, 6, and 8. That is the answer. I know it's a little crazy, but that's the reality. Once you start working with more complicated situation, when you have 3 sets, it gets more challenging. So this would be probably a good approach to use, because you can actually visualize all the intersections and unions. Alright, so now we have to use set notation to describe each given set. I think example A is easy. What we have shaded here is everything outside of A. This is the complement of A. Right? What about B? Well, let's see. What we definitely have is what's outside of C. Right? So that's the complement of C, but that's not all. Along with that, we have this region here. This region here by itself is the intersection of A and B. So because it's not this region here, everything outside of that, forget about C for a moment. If you're just looking at A and B. This region here is the complement of the intersection of A and B. So A intersect B, the complement. And because you're basically taking this, along with that, this will be the union. So what we have here is the intersect of A and B complement, union C complement. This is the answer. Remember, with these problems you may also want to try to reverse it and see if what you wrote there, if you actually try to shade it, will be consistent with the diagram. Okay, so now let's talk about cardinality. So what we have here is the cardinality. These are not the elements of the sets, these are just the cardinality of each one of those regions. So that means that this part here contains 4 elements, this part here contains 5 elements, this part here contains 7 elements, and what lies outside of both circles contains 3 elements. So what is the cardinality, or the number of elements in the complement of A? Well, complement of A, so this is A. What's outside of A? We have 3 elements here and 7 elements here, right? So it will be 3 plus 7. That means it contains 10 elements. Just imagine, block these out, A. Everything outside of that will be the complement of A. You have 3 here and 7 there. What is the cardinality of A union B complement? To make this work, you first of all need to visualize what region you have. So, where is A union complement of B? The complement of B is everything outside of B, right? And also you're going to attach A to it. So everything outside of B, and you're attaching A to it, so you're basically just going to get what portion of this? You're going to get this portion here. This is A, no, I'm sorry, that will be this portion, right? The A, which is this, and you're going to do the complement of, I'm sorry, it's going to be everything here except this, because you have A, which is this circle, and the complement of B will be everything outside of B. So that will make up everything except what's in this. So for this portion is out. So you add all the other numbers. So that means it's going to be 5 plus 4 plus 3. That is 3, 4, 5. That is going to be 12. Right? Now, if you're a little bit confused with this, just go back. We had one example earlier that we did. I think it was like in the beginning of the video, where A union the complement of B are done. All right. So what do we have here? A intersection B. So the intersection of A and B lies here. That's this overlapping part. And you do the complement of that. Right? So the complement of that will be everything except that. That will be 3 plus 5 plus 7, which is 15 elements. And now you're doing the complement of A, which is everything outside of A, intersected with B. So everything outside of A is going to be this, everything that's not inside of this circle, and you're intersecting that with B, so the only part that's going to be overlapping here is going to be this crescent shape, right? And that one has 7. Again, it may be helpful for these problems to actually shade the corresponding regions. See our video earlier, you can go back and shade the corresponding region, draw it separately, and then you will be able to do this. Okay. So what do we have here? We have 3 sets, and now we have to pretty much figure out the same thing. Didn't label them, so that's A, that's B, and that's C. So what is the cardinality of the complement of B? So the complement of B is everything outside of B. So all the numbers that do not fall inside of B are going to be included. That's going to be 3 plus 5 plus 2 plus 6. Everything except these numbers here that are inside of B. So that's 5 plus 5, 16. I mean 5 plus 5 plus 6, 16. What is it for the A union B? So A union B is this part, right? And you want to intersect it with C. So imagine this part that is considered, and you're intersecting it with C. This is the part that they are going to share in common. So these 3 numbers here, 3 plus 2 plus 1, that is 6. What about the cardinality of A intersect the complement of B? So A contains this here, right? The complement of B will be everything outside of B, so that for this set here, so we're doing again, we're doing A intersecting but not B, so that will be just 5 and 2. So that's 5 plus 2. And we do a union with the complement of C. The complement of C is everything that's outside of C. So for that one, everything outside of C, we got these 3 plus 5 plus 4 plus 8. Okay? But we need to be careful here because we have some overlap, right? So when you look at A already has 5, I'm sorry, the intersection here is going to have 5 and 2, right? And we do not see, we already included them, we included this 5. So that 5 cannot be counted twice, we're going to have to remove that. Otherwise you count these elements here in this region twice. So all in all we're getting 5 plus 2 plus 3 plus 4 plus 8. So this here will be 10, 14, 22. Okay. Got one more example here, which is a pretty challenging one, because here you need to figure out things. So what do we have here? We have the cardinality of each of these sets that's given to us, and we're gonna have to figure out what what this final answer is, because this is what we're trying to find. Okay, we're trying to find the cardinality of the intersection of A and B. But we're gonna have to figure out all these numbers. So let's start with this. So this is the intersection of A and B and C. That is this part, that's where all three of them overlap. So right here you're going to have 5. So that's already done. The intersection of A and C, which is this part right here, the intersection of A and C contains 14 elements. So between this and this you have 14 elements. So if this has 5, this will have 9. Okay, so we got these done. The intersection between B and C, right here, 11. You have, so between this and this you have 11. That means this one has to contain 6. C contains 31 elements. So C is this whole thing, right? So out of that, we already have 5 plus 6 plus 9, that's 20. And this whole thing contains 31. So that means this part contains 11. So we got these done. What else do we know? We know that we have the intersection of A and B, which is this here, contains 9 elements. Between these two things you have 9. This one has 5, so this one will have 4. Now all we need to do now is we need to figure out all the remaining, well actually we need the intersection of A and B, right? And this here is the intersection of A and B, so inadvertently we I think I actually meant to find the union. Yeah, let's do the union, my apologies. So we're trying to do the union, so we still need to find the number of elements here and the number of elements here. So we know that in between A and C you have 45 elements. So right here you're gonna have 45 elements. So what do we have so far? We have 11 plus 9, 20 plus 11, 32 plus 4, 32 plus 4 is 36, and over here we have 45, so this will be 9. So we use that, and B and C, so between these two things here, you have 47. What do we have? 20 plus 11, 20 plus 11 is 31, 35, and we have 47, so this has 12. So we're trying to do, again, my apologies about the confusion, but we're trying to do the cardinality of the union of A and B. So between A and B, how many elements do you have? You have 9 and 9 and 4 and 5 and 12 and 6. So 9 plus 9 plus 4 plus 5 plus 12 plus 6. So that's 18. 22, 27, 39, 39 plus 6 is going to be 45. Okay, this is how it's done. These problems are a little bit more challenging and they do take time, and you need to be very careful with the arithmetic here. Otherwise, they're not too complicated. I hope this helps.